Hi everyone, welcome to Lesson 6, Laws of Logs. This is the sixth lesson in our Exponents and Logs unit. We have an opener question here. It's talking about transformations of y equals log 5x to this new equation here. To do this question, the very first thing I notice is I need to manipulate to get rid of this 1/4 and to factor so that we have a dedicated b value. So I'm going to do that all in one go. So I have here y equals, instead of going 1/4, it's going to now be 4 on this side of the equation, log base 5. And in bracket, I'm going to factor out a -3. That leaves me with x minus 4 to get me back to 12 there. Double bracket plus 8. And there we go. That's our equation factored. Of course, now as descriptors, we have vertical stretch by a factor of 4. We have a reflection on, and if it's inside our function here, which it is, it's a reflection on our y-axis. You have that 3, which is a horizontal stretch by a factor of 1/3. You had to reciprocate that. You have a horizontal translation 4 units to the right and a vertical translation 8 units up. And there we go. That's our opener question. State our domain of the transformed function. So our regular domain should have been greater than 0 because our regular picture should have looked something like this. With a reflection on our y-axis, it should look something like this over here. Shifted, no, our regular one should have looked something like this. Let me try to draw that again. So our regular graph without anything should have looked like this, and with the transformed, we would have shifted it to the right, reflected it over the y-axis and 8 up, so it's looking something. There's an asymptote, by the way. Looks something like this over here. So what's our domain? It's gonna be everything. Initially it was everything greater than 0. Over here we're gonna be everything less than. We shifted it 4 to the right, so less than 4. So our domain here is going to be from -infinity all the way up to +4, but not including 4, because that's our vertical asymptote. For this one here, it says evaluate the following in this question here. Evaluate the following: log base 2 of 32 plus log base 2 of 8. So what do? Options. We have options here, so we can evaluate each of these logs individually and then figure out our answer in total. So that's what I'm going to do. So this first one here on the left is basically 2 to what exponent would equal 32. And of course, if you have your power table or you use your graphing calculator, you know here that x had to be 5 because 2 exponent 5 equals 32. Over here, we're asking ourselves the same thing. 2 exponent what? Let's call it y this time, equals 8. And of course, that has to be 2 cubed equals 8. So if we know what the x and y are, really, this is saying what is 5 plus 3? And here, that's just 8. So 8's our final answer for this first one. Let's go to this one over here. Over here, if you want, what we could do is we can multiply these two in brackets here together. Let's do that first. So this is now log base 2 of, well, whatever 32 and 8 is. 32 and 8 is 256. So here, what I want to do is solve for 2 exponent x equals 256. So x has to be equal to 8 in this case here, and that will get us 256. So this logarithmic equation will equal 8. Down here, we're doing the same question as part A, but this time we're subtracting. So we already know what our numbers are. They were 5 and 3, so this time I'm going to go 5 minus 3 right away. And of course, this one here, simply equal to 2. Over here, if we're dividing, let's see what we get. So if we divide this as log base 2 of 32 over 8 is just 4. So let's bracket 4 there. And here you're asking yourself 2 exponent what? Therefore, 2 exponent what equals 4, and of course that x has to be, x has to be 2. And there we go. I'm going to use my therefore symbols everywhere. I just kind of forgot, and that one there is equal. And there we go. We've evaluated these for logarithmic equations. So that leads us right into our laws for logs here. So this first one here is basically saying if you had log base c of m multiplied by n, you could separate that into an addition question. So that's the same thing as saying something like we just did it, by the way. If you had something like log same base, let's go base 2 of, let's pick a number, let's go with 4, plus log base 2 of, and let's pick another number, let's go with something like 8. That could be the same thing as saying log base 2 of, well, what's 4 times 8 together inside a function, and so that's log base 2 of 32. So 32 can be ripped apart into 4 and 8. Here this is saying that if you're dividing, you're just subtracting, and this basically follows the same rules as your exponent laws, but it's our log laws. So here it's if you are dividing, you're just subtracting, and again I don't really need to write out an equation for that one, but just be aware that if I set up an equation of log, let's go with base 10 this time, base 10 of 4 minus log base 10 of 2, this is the same thing as saying log of 4 divided by 2 there in brackets. Okay, so that's how you'd set this one up. So whenever you see subtraction, it's just going to be a division statement. Here this is your power law. So this means that if you had a number or a coefficient in front of your logarithmic equation, you can bring it up as your exponent. So the example here could look something like if you had 5 log base 3 of, I don't know, let's go 3 of 7 just for sake of different numbers. We can rewrite that as log base 3 of 7 exponent 5, and that should be in brackets there together. There we go. Change of base is just change of base. That means you're just going to write this in terms of base 10, and that's what that is there. And this usually is used for TI-83s or older, so this is usually used on the TI-83. Anything newer like the 84s, you really don't need this. You have a button in your calculator that could do that for you. So evaluate the following laws of logs. Here we go. So let's rewrite these into, it says evaluate, and then let's first rewrite this into a giant equation. So here I have log, and double check all your bases 5, 5, and 5. So yeah, I can rewrite them all into log base 5. Let's see what happens. Well, if I'm adding, really these two are going to be multiplied. So I got 10 multiplied by 125. And whatever that answer is, I'm going to be subtracting by log base 5 of 2. So subtraction means we're going to divide whatever that numerator is by 2. And there we go. What I want to do is try to simplify this down. So this is log base 5 of 1250 divided by 2, which is log base 5 of 625. And now you can ask yourself or type it into your calculator. I would type it in now to your calculator. Log base 5 of 625. This is now just equal to 4. Done. Or, of course, you could have asked yourself 5 to what exponent would get you to 625? That exponent had to be 4 anyways. Over here, what do we have? We have a coefficient in front of each, so let's move those out of the way. That's going to be my first step of rewriting. So I have log base 2 of 16 to the exponent 1/2 minus log base 2 of 8 to the 1/3. There we go. So now we have no more coefficients to worry about. Next step, we should probably, if we can, let's evaluate those. So we have log base 2 of, well, 16 to the exponent of 1/2 is the same thing as saying square root of 16, which is just 4. This is going to be minus log base 2 of, well, this here, 8 to the 1/3 is just cube rooting 8, and that's going to be 2. Here, it's a bit easier to clean up, so I know subtraction is division, so I'm going to rewrite this as a division statement. So this is log base 2 of 4 divided by 2 now. And of course 4 divided by 2 is just 2. So I have log base 2 of 2 here. And this is a special case, by the way, but this is asking you 2 exponent, what gets you to 2? That exponent had to be 1. And there we go. For the next example here, for our next example here, we have 3 log x minus log 3 cubed. So first things first, I'm going to switch this this coefficient out of the way. I'm going to move it out of the way. So I'm going to move that and have log x cubed minus log x cubed. Well, of course this is going to be 0 because this is the same thing being subtracted, but let's just write it out in full. I know subtraction is the same thing as saying log x cubed divided by x cubed, which of course is just 1. So this is log of 1. And anytime that you have log of 1, your answer had to be 0 because this is base 10. Base 10 to some sort of exponent equals 1 had to be 0 there. And of course, right away we saw that 0 as well, so both methods would have worked. Over here, let's rewrite this into a giant log statement. So here we have, again, double check all your bases. They're all base 3s first, so we're good. So we have log base 3, and let's see what's happening. So here we have 3 plus 2, so that means it's going to be 3 multiplied by 2. I have a division, or I have a subtraction statement, which means division, so I'm going to divide by 27. But I also have another subtracted by 6, so that means I'm also going to be a division, so I'm going to be right there. 6 is going to be dividing everything else there. Close bracket. Let's clean this up. So we have log base 3 of 6 in my numerator, 27 times 6 in my denominator. Here my 6's and 6's will cancel out, leaving me with log of 1 over 27. There should be a 3 here. Log base 3 of 1 over 27, which I can simply rewrite as log base 3 of 3 to the negative 3 exponent. So I reciprocated that 27 and I rewrote it in base 3. And this answer here, log base 3 of 3 with an exponent of negative 3, this is just equal to negative 3. And again, this is a special case that we talked about the other day. Write each expression in terms of individual logarithm. All right. So basically this is asking you break this apart into its own individual pieces before we combine it all together. So I know that multiplication, there's addition there. I see division, that means subtraction. So here we go. I have log base 7 of x. So that's the first term I see. I see the multiplication, so that means we're going to add. So let's put our addition sign right there. We're going to add on a log base 7 of y squared. I believe that's a y squared. And the division statement means we subtracted, so I'm going to go subtraction after all this. That's going to be subtraction of log base 7 of z. And there we go. We have our equation. But here I'm just going to clean this up one more step. So this is going to be log base 7 of x plus 2. So this 2 from that y jumps down in front, goes to become a coefficient. Log base 7 of y minus log base 7 of z. And there we go. Over here, let's rewrite this one here. So I see a 16, so that's where I'm going to start. So I have log base 4 of 16. And if it's multiplying, that means we're adding. So that's adding on log base 4 of square root x. I see a division statement, so let's rewrite that as a subtraction statement. That's going to now be log base 4 of the cube root of y squared. And there we go. From here, if you can, let's try to simplify or clean up, but this would have been good enough to write each as individual logs. But this first one here, it's purely numbers. So I got log base 4 of 16, so 4 exponent what gets you to 16? That'd be 4 to the exponent 2. So it's going to be 2 plus this radical I'm going to rewrite as log base 4 of x to the 1/2. And if I have an exponent, I'll most likely move it in front as a coefficient. And this is minus log base 4. And same idea here, rewrite that radical as a exponential. So that's going to be 2 over 3. And I'm going to rewrite this one more time as 2 plus 1/2 log base 4 of x minus 2/3 log base 4 of y. And there we have it. In example number 3 here, we're asking you write each as a single logarithm. So you're going to combine everything together in this case here. So it's very similar to number 2, or sorry, to example 1 that is. So here the first thing I see is a coefficient. I'm probably going to move that up, and then I'm going to start rewriting everything. So I have log of x minus log y to the 1/2 now. And this is going to be plus log z. So right away, when you add or subtract, you can almost do it in any order. So I'm going to do my addition first. So this is the same thing as saying log. And again, addition meaning that we're multiplying. So this is x multiplied by z. And all of that's going to be divided by y to this 1/2 exponent. And there we go. And we want to leave it like that there. Over here, let's rewrite this one here. So this is log base 10 of x minus log y to the 1/2 minus log of z. So in this case here, we have log base 10 x there up top. We have that subtraction right away, so that means division. That's a y to the 1/2. And again, another subtraction, so that's z in your denominator as well. Again, you could have done log x minus log z, which would have forced z to be in denominator first anyways, and then whatever that was, subtracted by log y to the 1/2, which would also be in denominator, so both are always down there together. In example C, we have log a, and this time we have brackets, so there's some sort of ordering going on there, so don't forget, because it's also subtraction. So here we have log a minus, so this 2 I'm going to move up, so this is now minus log b squared plus log c. And why is it plus? Because 2 negatives there would have made it a positive. You distributed in that negative there. So let's rewrite this. So this is now equal to log of a times c in our numerator, all divided by b squared in our denominator. There we go. Over here, I'm going to move all my coefficients up, of course. So let's start there. So log a of p to the 3/2 plus log a q cubed minus log a p to the 1/2. Alright, and in this one here, let's rewrite this. This is now log a of You have p to the 3 halves multiplied by q cubed, all divided by p to the 1/2. If you can clean up, you can clean up. I'm going to figure out my p's here. Really, we're just subtracting because it's exponent, so 3 halves minus 1/2. I'm left with log a of 2 over 2, which is just 1. So it's just p multiplied by q cubed. And there we go. That one's there, done. For E is a bit of a tricky one. I'm going to put a star next to E here just because we have a number in this case. Again, we still want to combine everything together, but what does this number really mean? Let's rewrite this. So this is log, our base is C, by the way, C of C. That's what 1 is. So log C of C, again, special case, that's equal to 1. Just an FYI. Everything else I'm just going to copy down the same. So log C of m exponent 5 minus log C of m. And let's combine everything together now. So this is log base C of C multiplied by m exponent 5 divided by m. And of course m's would cancel. So you have log base C of C multiplied by m to the exponent 4 because you had 5 and technically 1 there. Subtraction gets you to 4 overall. And over here, again, I'm going to start by get rid of all my coefficients by moving them up. So I have log base log base 2, a that is, 2a, log base 2 of a to the 2/3 minus log base 2 of b to the 5 minus log base 2 of c cubed, and that is going to be multiplied together by the 1/2. Oops, 1 over 2. There we go. Let's combine everything together because it's all the same base right now. So we have log base 2 of a to the 2/3 numerator. Denominator is going to be b exponent 5. And this c, if you multiply it together, 3 halves. And there we go.